Okay, so we are going to go ahead and try to write a small code to search for an element in a big list. Firstly, let me tell you how to create a big list. Alright, so how do we go about it? You can always type in a big list like this, right? 99, 6, 4, 1, 4, 4, 86, and so on. That is the biggest list I could type in less than 10 seconds. But if you want to type a bigger list than this, there's a way to do it. So how do you do it? Say import random, and then let's say for I in range 10,000, you append to the existing list, let's say whatever you have created here, or maybe you can remove the numbers here. Okay, L append random rand int, let's say 1 comma so much. How much is this? 1 million. From 1 million numbers, 1 to 1 million, I'm picking a few numbers. Close the bracket, and there you are. As I've been telling, you can type the code here itself on the terminal. Okay, but then when you type it here, you can execute it repeatedly. Once typed here, you may not be able to execute them in sequence. But nevertheless, let's see what is in L. Oh wow, L has so many numbers. Okay, so you cannot scroll it, there are plenty many. So what you do is, yeah, I mean, it can be a little buggy at times because you're generating so many numbers. Scrolling up, scrolling down can be a problem. So I repeat once again. So what do I have? Import random, and then I say I create, let's say, a list. I'm sorry, bear with me. So I create a list L. What exactly did I do? I created a list L, and then I populated the list with some 10,000 numbers, or maybe let's say 100 numbers, just so that it becomes easy. It doesn't scroll much. Okay, and it's easy to see, easy on the eyes rather, right? Okay, say enter, and you get 100 elements here from 1 to 1 million. Okay, so far so good. So then this is a big list, but I want a very big list. So what do? I start with L equals so much, and then firstly, of course, import random. Don't forget, we are trying to create a big list. Okay, for I in range, a big list, I want, let's say, 1 million numbers in it. Okay, this is 1 million numbers. L append random rand int in the range 10 million. From 1 to 10 million, I'm picking 1 million numbers. Okay, so yeah, now the list L will be ready if I execute this. I'm executing it. I'm expecting it to take some time, but it was really fast, very good. So if I say print of L, it will give me once executed. As I said, the variables will be there. You can execute, and now you see L here. Okay, as you know, L of 0 will be the first element. L of 1 will be the second element. How do you see the last element? Len of L minus 1. Okay, so it does get stuck like this. This is very common whenever you handle a big list, and you know, your memory is full, and even your Python compiler requires some memory, your internal memory, also called the RAM. So this is very usual. You should get used to it whenever you handle a huge data. Okay, so the last number is 7891012, and that's precisely what you see here. Okay, I would like to check if there is a number. Let's say I'll type that here. Okay, so please don't mind the lag here because I'm generating big numbers. It can cry like this at times. Okay, so what's happening here is I had scrolled up and scrolled down, and it's happening slowly whatever I did. Okay, so what I do is I say element let's say A equals 5 6 7 172. Okay, and I would like to check whether this is there in L or not. So how do I go about it? For I in range, length of L, so which means I runs from 0 to up to the length of L minus 1, the whole of the array. Okay, if A is equal to L of I, print hip hooray, element found. Otherwise you should print element not found. So as I've been saying, what you will do here is you will keep a flag variable. That's the most complicated thing in programming, you know. So as we have discussed already, I'll not go in detail about this. You already know what this does. It will be sort of self-explanatory. So once you find the element, you break from the for loop, right? And then if flag is equal to 0, then you say element not found. Okay, so what's happening here? I think, you know, a good way to illustrate this is to actually not use the for loop. Let's say I'll comment this. Please get used to commenting. Right? So I'll type in a small array here, a small list here. Okay, 1 7 42 89 6 5 6 7 1 7 2 64 883. Okay, your element is definitely here, right? So what happens now when you say A equals 5 6 7 1 7 2? I'll just remove this for loop just so that. So what I'm not trying to confuse you people. All I'm trying to do is I am trying to keep the list smaller. Okay, once you make it bigger, it doesn't matter, the program still runs, but it will be easy on your minds if I keep the list smaller. I realized it as I was programming, so I'm doing it right now. Let it not confuse you. The programming is pretty simple and straightforward. All I'm doing is I initialize flag with 0 and I say I declare a variable A to be the number and check whether this number is present in the list or not. Okay, so I run I through the entire L, and in case this value A is equal to any value in L, I print hip hip hooray, I create flag equals 1 and then I break, which means flag is no more 0, right? Which means this will not get executed in case you have seen the element, right? This will only get executed if flag never became 1. So if flag equals 0, then it says print element not found. These programs might appear a little complicated to you to begin with, but with time you will get used to it. I just executed, it says hip hip hooray, element found. Just in case I were to type in some other element, let's say 5 6 7 is not here in this list, right? It should say element not found. It indeed says element not found. Now what we will do is I will include the for loop. You probably are wondering, sir, what is the big deal in seeing whether 5 6 7 is there in this list or not? It's obviously not there. It's visible for my naked eye. Why do you write a program for it, right? So that is when the complexity question pitches in. What if this list is not as simple as it appears here? Let me remove it. Okay, let A be 5 6 7 only, and I am appending several, how much is this? As I was telling you, some 10 million, from 1 to 10 million, I am appending a random number a million times. A random number as big as, let's say, 10 million, 1 to 10 million. A million times I append. Just stare at this for loop for a minute. Okay, and in that L I am going to search, right, for 567 if it's there or not. Okay, I'm executing it. Boom. L is not defined. That's because I made an error here of not initializing L. So simply I am appending to the list L. The list L should exist. Unless it exists, I cannot append it. As simple as that. This kind of mistakes even you will be doing. We are not going to edit these mistakes because these mistakes do happen. You must feel confident that everyone makes mistakes, and such mistakes when you make, you know how to fix it. Okay, so I run this and I get hip hip hooray, element found, which means A equals 5 6 7, this particular list generated. Okay, this particular for loop, random number when I was adding, 567 got added. So let me execute it once more. Now element not found. 567 did not get included in this list. Alright, so he was wondering, why would we want to write a program like this? You're generating random numbers and you're finding a number there. Will this be the beginning of the world or the end of the world? Why are we even writing a program like this? I am trying to tell you that you can do certain things really fast. Okay, many of the mundane things that we do in our life can be done really fast if we can write a piece of code. Of course, we struggle in writing a simple piece of code like this, but then that's how programming is. But at the end of the day, you automate things, you see, execute it, and a big list gets created and it says element not found. Right? Okay, so now let me modify this slightly and then try to ask you to type in for an element. It will check whether the element is present or not. So what should I do? I have a list L. Now list L is generated. It's a big list. Now what I'll do is I will print enter a number. Okay, and after that I'll take the number that you enter. Okay, input. As you all know, this should be integer. Okay, and then I'll initialize flag equals 0 and check if n is present or not. Okay, so instead of a, I'll put n. In fact, I could have called it n, a itself there, but never mind. So I have all these things. Perfect. Print enter a number. All right. So let's go ahead and then do this. But then what I want is this to be repeatedly called. What do I mean by that? Enter a number, type -1 to exit. What do I mean by that? I'll tell you. So what happens here is I'll say while n is not equal, while n is greater than -1, okay, then do this. Okay, so anyway, let me use okay, so perfect. So I'll just go ahead and then execute it. It says enter a number, type -1 to exit. I say 78. It says element not found, element not found, element not found. It's not stopping. That's because I made an error here. I made a mistake here. Let me stop this. I want this to be interactive. Okay, I'll put this inside. What do I mean by that? You will get to know. This enter a number, type -1 to exit should keep happening. Right? Okay, so I'll initialize n to be, let's say, 0. Okay, n is 0. I need to initialize n. That's why it's throwing an error here. N is 0. Please don't worry about my editor throwing errors. You know, that's how we all code, right? That is when logic converges, right? This is how you should get comfortable coding. So n equals 0 initialized, and then while n is greater than -1, definitely yes, n is greater than -1 because n is 0. It enters here. It says enter a number, type -1 to exit. I execute. It says enter a number, type -1 to exit. I say 19876. It says element not found. Enter a number, type -1 to exit. I type some random number. It says element not found. I can keep doing this, keep doing this, keep doing this. In fact, none of these elements that I'm trying to find is present. So I'll type -1 and I'll come outside. Okay, so a good illustration is actually to type a list of your choice. Maybe you can type a list of all our date of births. Maybe there are 2001 borns here. I'm sure there'll be some 1990 borns here, 1981, 1985, 2000. I'm sure all of you are 18 plus, so the minimum would be 2003 and so on. I'll type some numbers here, 1988, 1999 and so on. Okay, so now when I execute this, I'll comment this just so that you can see whether the program is running fine or not. In fact, if the number is, if you're typing a number that's present here, it should say present here, otherwise no. So I say 2001, it says hip hip hooray, number element found. I say 1981, it says hip hip hooray, but then as you can see, the year 2000 is not here. So if I say 2000, it will throw an error. By error I mean it will say number not found, and that's indeed true. The number isn't here in the list. Right? So using the for loop, I created a big list just so that you realize even the, it's like finding a needle in a big haystack, but still your program goes ahead and then finds it. Some of you are wondering, why am I writing such a complicated program? Some of you are wondering, why are we talking so trivial things? Right? So please be patient. As always, I've been telling this, we are going to make things complicated for you slowly. So this week's discussion, as I've been telling, is about a few pieces of code. I mean, some 8 to 10 codes, the programs that we'll be revisiting again and again. There's a reason why I'm introducing this searching for an element in a list. As boring as it can get, but it will get very interesting. In fact, we will try to see how you can find a small word in your browser. You always type this Control F, right? How exactly does that work? You basically are starting with chapter 1 of that search, right? So what's the moral here? I mean, what's the bottom line here? Bottom line is that no matter how big the list is, we can search for an element there. In a very seemingly big list, very, very big list with around 1 million entries, you can go ahead and search through the entire thing and stop when you find the element. Alright, so you may want to retype this code many a times and then get familiarized with it. We will now go ahead with sorting in our next video.